Hello! In this video, we're going to look at the tests and color changes you need to know for identifying ammonium ions, hydroxide ions, halide ions, carbonate ions, and sulfate ions, as required for AQA A-level chemistry. Ammonium ions can be identified using sodium hydroxide and damp red litmus paper. Approximately 10 drops of sodium hydroxide solution is added to the sample in a test tube and a test tube gently heated in a water bath. Any fumes produced are tested using damp red litmus paper. If ammonium ions are present in the sample solution, the damp red litmus paper will turn from a red to blue color. This test works on the basis that the sodium hydroxide added reacts with any ammonium ions in the sample, forming ammonia and water. As the solution is gently heated, the ammonia leaves the solution as a gas. This ammonia gas released then reacts with the water on the litmus paper, forming ammonium ions again and hydroxide ions. The hydroxide ions cause the color of the litmus paper to change from red to blue. This is why red litmus paper is also used to test for hydroxide ions in solution. Aqueous halide ions, chloride, bromide, and iodide, can be identified by using their reactions with aqueous silver nitrate followed by ammonia solution. Nitric acid is added to a sample solution followed by aqueous silver nitrate solution. If any of the three halide ions are present in the sample solution, insoluble silver halide precipitates get formed. If chloride Cl- ions were present, a white precipitate of silver chloride, AgCl, gets formed. If bromide Br- ions were present, a cream precipitate of silver bromide, AgBr, gets formed. And if iodide I- ions are present, a yellow precipitate of silver iodide, AgI, gets formed. The precipitates can be difficult to distinguish as the colors of each can look similar. To get around this, dilute and concentrated ammonia solutions are added. Silver chloride, AgCl, dissolves when dilute ammonia solution is added. Silver bromide, AgBr, doesn't dissolve if dilute ammonia solution is added, however will dissolve if concentrated ammonia solution is added. Silver iodide, AgI, won't dissolve in either dilute or concentrated ammonia solution. Nitric acid is added before the silver nitrate solution at the start to react with other anions present that may cause precipitates to form with silver ions. For example, if any carbonate ions were in the sample solution, they would react to form silver carbonate, also a white precipitate. By adding nitric acid first, however, any carbonate ions present react with the nitric acid, forming carbon dioxide and water. This means when the silver nitrate solution gets added, silver carbonate can no longer form, and any precipitates that do form will be from the halide ions reacting with the silver nitrate. Carbonate ions, CO3 2-, can be identified using a weak or dilute acid and lime water. A dilute or weak acid is added to the sample solution in a test tube. Dilute hydrochloric acid is often used. If the solution contains carbonate ions, gas will be produced and effervescence observed. The gas produced will be carbon dioxide. Just to confirm that the gas is carbon dioxide, it can be bubbled through a solution of lime water. A color change of colorless to cloudy should be observed. This test works on the basis that the carbonate ions react with acid to form carbon dioxide and water. The carbon dioxide produced won't all be able to dissolve in water, and most will be released as a gas. Lime water contains calcium hydroxide that is colorless when dissolved in water. When this solution mixes with carbon dioxide, calcium carbonate, an insoluble white precipitate, gets formed, turning the solution from colorless to cloudy. Aqueous sulfate ions, SO4 2-, can be identified by using hydrochloric acid and aqueous barium chloride. Hydrochloric acid is added to the sample solution in a test tube before barium chloride is added dropwise. If the sample solution contains sulfate ions, a white precipitate of barium sulfate, BaSO4, will form. Hydrochloric acid is added to the sample solution first to help react with and remove any other impurities that may cause a precipitate to form. It should be hydrochloric acid that is added rather than sulfuric acid, as otherwise sulfate ions from the sulfuric acid would react with the barium ions from the barium chloride to form barium sulfate. I hope you found this video useful. Please check out other relevant videos in the description below and visit chemistrystudent.com for free notes and resources.